Hello all. So today we are going to deal with the topic probability. Probability is a chance of an outcome or an event. And this probability we are studying from a lower classes. Probability predicts the likelihood to happen or not to happen for an outcome or an event. For example, it can be tossing a coin. When we toss a coin, it can be head or tail. We can't predict it before tossing the coin. The other example can be throwing a dice. A dice has 6 faces, so any face can come when we throw a dice. And chances of rain, drawing a card from a pack of cards. Probability is the numerical value of the possibility of the occurrence of outcome for an uncertain event. Probability can range from 0 to 1. 0 means an event is impossible one. And 1 means an event is certainly can occur. The number between 0 and 1 will give you the probability of an outcome of the event. The probability of an outcome will always be positive and it always lies between 0 and 1. There cannot be a negative probability for an event. These probability distributions are nothing but the possible or probable nature or the distribution of result or an outcome which is in the form of numerical data, which can be also obtained from random experiments and events. A variable is an event of a parameter which can be quantified and varies from one value to the other. This probability distribution can be categorized into two: discrete probability distribution and continuous probability distribution. Discrete probability distribution examples are binomial distribution, Poisson distribution and uniform distribution. And in continuous distribution, normal distribution comes. Next we are going to deal with the important terms that we use in probability. Sample space. Talking about sample space, it is the whole sample we are looking while doing the probability. So, the set of all the possible outcomes to occur in any trail. Example, tossing a coin. The sample space can be head and tail because the sample coin has two faces, that is head and tail. So, the sample space in tossing a coin is head and tail. Rolling a die, another example. So here the sample space can be from 1 to 6. 1, 2, 3, 4, 5, 6 because of the 6 faces it has. Next is experiment or the trial. It is a series of actions where the outcomes are always uncertain. We do not know what is outcome of that event going to happen. For example, it is also the tossing of a coin and throwing a dice, a chance of rain, or taking a card from a deck of cards. In a deck of cards, we don't know which card will be coming first. So these all comes under experiment or trial. Event. It is a single outcome of an experiment. While tossing a coin, we can say that only one comes, head or tail. Both the faces will not come while tossing a coin. That is, head and tail will not come together, either head or tail. So it comes under event. So it is a single outcome of the experiment. The formula for probability. Probability of event to happen, that is equal to the number of favorable outcomes divided by number of possible outcomes. For example, when we take a coin for tossing, the total possible outcomes in that will be 2 because of the presence of head and tail. And tossing a coin for one time, the number of favorable outcomes is equal to 1. So, the probability of tossing a coin is equal to 1 by 2, that is 0.5. And taking another example, throwing a dice. So, throwing a dice, the number of possible outcomes can be 6 because it has 6 faces. And the number of favorable outcomes throwing a dice for one time will be 1. So, probability of throwing a dice is equal to 1 by 6. Next, we are going to deal with the symbols of probability. Probability of A. That means the event A is been happening. And probability of A prime. It is the probability of event A is not been happening. Probability of A union B. That U shape is indicating union. It means that the probability of event A or B, either A or B, is going to happen. And the next symbol shown is the probability of A intersection B. So the downwards U is indicating intersection. And this means that the probability of event A and B together is going to happen. Now we can take an example as a question. Calculate the probability of getting head when a coin is being tossed once. So the sample space here is 2. That is all the total outcomes that is included in that sample. So here taking a coin we have head and tail. So the total outcomes is 2. Number of favorable outcomes as it is being tossed 1 is equal to 1. So probability of getting head is equal to number of favorable outcomes 1 divided by total outcomes 2, so that we get the answer 0.5. I think everyone has got this. The next we are going to deal with is the laws of probability. The first is addition law of probability. When the probability is to find for happening of any one of the events, then additional law of probability is being applied. That is, when an event is occurring, only one event can occur at one time. For example, tossing a coin, we get only head or tail, either head or tail at a time when we toss a coin. Or throwing a dice, in the 6 faces we get only one face at a time. So at that situations we use additional law of probability. And this additional law is divided into mutually exclusive events and non-mutually exclusive events. So this additional rule of probability has 2, as I said before, mutually exclusive event and non-mutually exclusive event. So here in this picture we have shown A and B. So we can consider it as 2. So probability of union A and B is equal to the probability of A plus probability of B. So in mutually exclusive event, either one can happen at a time. So here we can take probability A is happening at a time and probability of B happening next. So to get both these probabilities, we have to add these and we can get the end result. In non-mutually exclusive event, the probability of A we have calculated and probability of B, and we should subtract from that probability A intersection B. Here A intersection B means that the two events occur same time. And as I said before, non-mutually exclusive event indicates the events that can happen together. Here we have shown the Venn diagram of non-mutually exclusive events. Mutually exclusive events, that means two events are mutually exclusive when they do not occur at the same time, when one event prevents the occurrence of another event of the sample space. So, tossing a coin, we can have head or tail, not both at a time. And in the deck of cards, we can get either king or queen and not both. We can get anything, king, queen, ace, or spade, anything we can get. So it also comes under mutually exclusive events. So as I said before, probability of A plus B is equal to the probability of A plus probability of B, and doing this we can get the end result. In non-mutually exclusive event, it is defined as the event that can happen at the same time. For taking example, in a deck of cards, the probability of getting black card and ace. Is it possible? Yes, it has been possible because there are 26 black cards and ace is also present 4, and black card has 2 ace. So the probability of getting black card and ace together is possible. So it comes under non-mutually exclusive event. Here the formula is probability of A plus B is equal to probability of A plus probability of B, subtracting from that the probability of A intersection B. That together we get no. So subtracting it from individual probability of A and probability of B. Now we can deal with the question. The probability of getting ace or king in a deck of cards. So ace or king in a deck of cards. So here, while taking a card from the deck of cards, you can get either A or either king. The both we can't get together. So this question comes under mutually exclusive events. For dealing this question, we can take the probability of ace first. So we all know that total number of cards in a deck of cards, playing cards, is 52, and in that ace is 4. So the possible favorable outcomes comes 4, and the total possible outcomes is equal to 52. So probability of ace is equal to 4 by 52. As such, for probability of king, the cards of king is 4 and the total possible outcomes is 52. As such, 4 by 52. Calculating the probability of ace and king, we can add both this of ace and king. So we get 8 by 52, which is equal to 2 by 13. The other question is probability of queen or black in a deck of cards. So here queen or black is given. So in black color there will be presence of queen. No, yes. So this question comes under non-mutually exclusive events because both these events can occur at the same time. That getting queen and black cards. So calculating this, we use the formula of non-mutually exclusive event. So as all you know, the cards of queen there are 4 and black cards are 26. So we should add first the probability of queen and probability of black and probability of queen in the section B. That is, there are 2 queen black cards. There will be 2 queen black cards in the full deck of cards. So 2 by 52. And we should add the probability of queen and probability of black and subtract probability of queen intermediate black. So the answer we get here is 28 by 52. The next is multiplication rule. If A, B and C are independent events on a sample space associated with a random experiment, then the probability of happening all of them is equal to the product of their individual probabilities. So here we deal with multiplication, and in this multiplication rule we have independent events and non-independent events and dependent events. Independent event. In probability theory, the outcome of one event will not be affecting the outcome of another event. This is called as independent event. So here the formula indicating is probability A intersection B equal to the probability of A individual multiplied into probability of B. And a dependent event, the outcome of one event will be affected with the outcome of the another event. Thus, that is called as dependent event. So here I have explained that independent event and dependent event. As I told before, the formula is probability A intersection B equals probability of A multiplied by probability of B. And in dependent event, the equation tells us the probability of A intermediate intersection B equals the probability of A multiplied by probability of B by A. So here B by A means it is dependent event. No. So one event is depending on the other event. So B by A means the probability of event B where event A has already occurred. And so it is the probability of event B but the event A has been occurred. Next we can deal with the question probability of head and tail. So while tossing a coin for once a time we can get head, and sometimes at the next time tossing next time we can get tail, but there is no dependency between head and tail. So here tossing a coin includes in independent event because there is no dependency between head and tail. Now we can solve this problem. Probability of head intersection tail is equal to head in the probability multiplied by probability of tail. So here both the probability of head and tail will be 1 by 2, and calculating it the answer we will get is 1 by 4. The next question is what is the probability of getting ace and king one after another from the deck of cards? That one after another I have not written in it, so I told now. What is the probability of getting ace and king one after the other from the deck of cards? So a bunch of cards has total number of cards is 52, all of you know that, and ace there are 4 in number and kings 4. So the probability of ace and king, here it is dependent event. Why I will tell you. Because from a bunch of cards we have taken one card first. So the total number of cards is 52. And from the 52 cards we have taken one card. So we can assume it as A. And the next time we are taking the card from the total number 51. Because before we have taken one card from the total bunch of 52. So the next time when we take another card, the total number will be 1 less from 52, that is 51. So the probability of K will be 4 by 51. So here the second event is depending on the first event. The total number has become 51 from 52. So that is the example of dependent event. So the next rule or law is complement rule. Here it denotes the events that are not occurring. The simple given is A prime or A subscript C. So the probability of A plus the probability of event not occurring will be equal to 1. So probability of event that happens is equal to 1 minus probability of event that does not happen. So for taking an example, probability of event while throwing a dice, the probability of not getting 6. So from the equation we can know that it is probability of A, that event happening, is equal to 1 minus probability of event that is not happening. So here the event not happening is 6, that we should not get 6. So 1 minus 1 by 6 is equal to 5 by 6.